let us continue our past year question discussion. Section C, part 2. So we're still at chapter 5, group 14 element. Okay, so in today's discussion, I will going to discuss with you all the questions after the years of 2013. So our discussion today will be also do the revision, okay? So based on the guided info from the notes. Besides that, so I try to also use the Laporan Peperiksaan so that you can know what is the point actually the MDM require, and also the mistake what the previous Stpm candidate already did. Look at the question number 7. Okay, so this is the question in 2013. Okay, discuss the acid-base properties of the oxide of the group 14 elements of periodic table. Write equation of the reaction involved. Okay, so here you can see the similar question which is asking also the acid-base property. You can see it's also come out at year of 2016, repeat 2, and then the 2007, section C, and 2006, okay? So at section B at our discussion for last few lessons now on, okay? Okay, so here the main point is you have to keep the acid and base properties, okay, for group 14 oxide. And here the marks involved is 10 marks. If I say you look at the other question, which is I stated similar here, so if there are only about 4 to 5 marks, but here the question emphasized to write the equation, so that you only can get the 10 marks. If you like, if you just give the discussion regarding the acid-base property of oxide group like previous question, so you will not get the 2 marks because you have to discuss the equation. Okay, and then here the question asking you to discuss the oxide of group 14 elements, so you have to discuss the train. Okay, you have to discuss the train. Later on, you can see like the example of 2006. The question asking you to compare the titanium and the to ask you to discuss about the certain certain element now. Okay, so you have to do the comparison. Later on, we have many almost same the question, but the way to write is different. Okay, so you can see from our notes also. So firstly, see the question asking you to give the acid-base properties of oxide. We have 2 groups. One is the monoxide. So from here, you can see for the acid and base property for carbon monoxide and silicon monoxide, they are neutral, so that they are not react with any acid and base. While for the germanium monoxide, tin monoxide, and lead monoxide, they are amphoteric, so they will be react with acid and base. So you have to give the equation for this amphoteric properties for these 3 of the monoxide. And then the second, you have to discuss another oxide of group 14, which is the dioxide group. So here, carbon dioxide and silicon dioxide will be acidic, and the germanium dioxide, tin dioxide, and the lead dioxide will be amphoteric. So that means you have to give the reaction for the carbon dioxide and silicon dioxide with the alkaline, and then the germanium dioxide, tin dioxide, and lead dioxide will be amphoteric. So you have to give 2 equations, which is reaction with the acid and base. So you have to try and relate the monoxide group is at the +2 oxidation state. Okay, and the dioxide group will be at the +4 oxidation state. Okay, so here you can see the reference answer for this question. So firstly, as I mentioned, you have to give the full state of oxidation for group 14, which is +2 and +4. And then we discuss the +2 group, which is the monoxide. So as per the table just now, carbon monoxide and silicon monoxide is neutral. So they will not react with neither acid or alkaline. And the germanium monoxide, tin monoxide, and lead monoxide is amphoteric. So that means you have to give the equation where 3 of the monoxide will be react with acid and base. Okay, so for the reaction with the acid, so they will form the salt. And then for the base, they will form the complex ion. So for +4 oxidation state of group 14, you have to mention that the carbon dioxide and silicon dioxide will react with the base because they are acidic. Because they are acidic, so they will react with base. So this is the equation. So where the carbon dioxide will form carbonate and the silicon dioxide form the silicate salt. So here I need to give another 2. Here will be 2. NO2. Okay, because we discussed the dioxide group. Okay, and then the germanium dioxide, tin dioxide, and lead dioxide. Okay, so they are amphoteric, you have to mention. And react with the base and acid. And then you give the equation for the reaction with base. They will form also the complex ion. And the reaction with acid will be form the salt. However, here, if the lead dioxide is react with acid in hot condition, so the lead 2 chloride will be formed with release of the gas of chloride. You can look at the Laporan Peperiksaan 2013 here. So what is the emphasis here? So you can see for this majority of the students, they will lose the mark because they not state the oxidation state. So that means most of the students not state this 2 oxidation state in the discussion. Okay, so as per mentioned just now, we have to give +2 oxidation for the group 14, which is the monoxide, and the dioxide will be +4. This is the first mark you have to give where majority of the students will lose the mark. So that means besides the question regarding the acid and properties, we are actually need to mention the +2 oxidation if the question asking you regarding the thermal stability of the oxide of 14 group also, or others. So all the oxide of 14, you have to give the oxidation state. Okay, to prevent that you lost the mark. So here already mentioned majority students is not mentioned. So that means in next time, if the question asking you regarding the any physical or chemical properties for the oxide 14 group, you have to give the oxidation state. And then second, so this one majority of students is able to give the example for the reaction between the monoxide and dioxide. Okay, so and then most of the students is compare the stability, but here the question asking you to compare the acid and base. And then we also not discuss about the reaction with water, so you don't need to mention all the not related properties because the question asks about the acid and base. So you just need to give the point which I boxed with the green already, the reaction of the monoxide, dioxide, and either they are neutral, acid, or amphoteric here, right? Okay, and then the most important part is you give the equation because the mark here is 10 marks. Okay, so according to the Laporan, okay, so many students give the unbalanced equation and wrong equation. Example here. So that means if you give the equation but it's unbalanced, it's also lost the mark. So you can see here we have about 6 equations here. So the question will be emphasized on the equation. So if we referring to the Laporan Peperiksaan 2013, So in future, if let's say question asking you this type of question, you have to give these 10 points here. Understand where you need to write and what is the common mistake did by the previous Stpm candidate. Oh. Okay, so the next tin is extracted from the mineral Peperiksaan, which is mostly tin 4 oxide. Reduction of the pure tin 4 oxide record is carried out in furnace at 1200 degrees Celsius. Okay, so the question asks you to calculate percentage purity of the sample of Peperiksaan is 300 grams extracted from 1.0 kg of Peperiksaan. Okay, so this is a process actually you already learned at your Stpm, your P3. So the input here will be the tin oil, salt, and then the output will be pure tin. So this is a Peperiksaan, okay? Okay, so firstly, the question already gives you that the tin 4 oxide is the main raw material. So the equation is started with tin 4 oxide where it is react with the salt. So the output will be tin and the carbon dioxide. So you have to give the equation because here we have 4 marks. And then the tin of the rest of the tin have to extracted. If we get 100% of the reaction now, okay? So here, this is a molar mass for the pure tin, and here divide with the molar mass of the tin 4 oxide. Here tin dioxide, so that we will get this. Multiply with 1 kg, we have to change to gram, so we get 788 grams. So the percentage, because in the question given that they're only able to extract 300 grams from 1 kg of the Peperiksaan, but actually for 100%, you will get 788. So we just divide and get 38.1% the purification. Okay, so here you can see again the Laporan Peperiksaan. Okay, so what is the common mistake made by the students here? Firstly, majority of students is not give the equation. They straight away do the calculation, so they will lose 1 mark. And then for the equation, you do not able to state the wrong formula for the tin oxide, tin dioxide. The tin dioxide is not TnO2 or is Sn, which is the stagnant dioxide here. Okay, and then the answer must be with correct units and correct significant figure. So if you preparing the question here, they are accepted for 2 significant figure and 3 significant figure. So this is a 2 common mistake did by the previous candidate. So you have to avoid the mistake here. Firstly, give correct significant figure, and then you have to give the equation so that you can get fully 4 marks here. Okay, for the next question, tin is a component of the many useful alloy. Set 1 use of the tin alloy, 1 mark. So from the revision info at section 4.12, uses of tin, we have many options here. So the alloy we discussed in the notes will be filter. The element involved will be tin, copper, and antimony. So it can be used as a souvenir, decorative item. So for solder, the element involved will be lead and the tin, used to join electronic or electronic circuit. Bronze will be the copper and the tin. So for sure, we discussed about the tin alloy, all must be contents of tin. So can be used for bronze can be used as a metal, statues, and ornaments and musical instruments. Okay, so from this info, what's the correct answer you can give? So here, alloy of tin, copper, antimony used as filter, making souvenir. And alloy of the tin and lead used as solder can be used to join the electronic circuit. And then the last here, you can write as the copper and tin used as the bronze can use in making metal. So the question seems like very easy, but here most of the candidate also wrong because they just give thin alloy can use for souvenir, example lah, can use for making souvenir is wrong, because you need to state what is the thin alloy mentioned here. So if let's say the usage you state as the souvenir, so that means the alloy you have to give pewter. So you must write pewter is used in making souvenir. If let's say you give the answer tin is used to make pewter, also wrong, because the question asks you the alloy of tin, which is pewter, solder, and bronze. Understand? So you have to state at least pewter, which is mentioned to the example of tin alloy and the use for the respective tin alloy here. So try to avoid the mistake here. So you give tin can use to make pewter is wrong, because we want the alloy of tin, which is pewter, solder, or bronze, and then give the respective usage here. Okay, so the next will be the section C again, question number 8, the question in 2013. Okay, so the first question is quite easy. Okay, state the general electronic configuration of the valence electron for group 14. So this one should be no problem lah. And S2 and P2 lah. Okay, and then discuss the train of electrical conductivity of group 14. Okay, so here we have to discuss the train. So this is also the similar question in 2012 and 2019. Okay, you can see most of the question will ask again and modify again the question which is already tested. So how we can get 4 marks? So this one also the info from our notes lah, section 4.5. So again, you can see here our note is meet the requirement for the question asked in 2019. The notes here mention that so the conductivity increased down to the group. So you have to mention this because we discussed train due to the increasing of the metallic character. Going down to the group of 14, the structure and element change from the giant covalent structure to the giant metallic structure. So here, the giant covalent structure will be carbon, silicon, and germanium. Okay, and then the tin and lead will be the metallic structure lah. Okay, so we discuss lah. Carbon, so the electrical conductivity increases lah from carbon to lead. And then firstly, for the carbon, here example will be diamond. It's a non-metal, so the energy gap between the valence band and conduction band is large, so that the electron is not able to jump to the conduction band from valence band. For the second is the germanium and silicon, they are metalloid or semi-metal, so the conductivity will be in between of the conductor and insulator. And we discussed about the energy gap between the valence band and conduction band is small, so the electron is still able to jump from the conduction band to valence band. And the last one is the lead and the tin, so they are metallic bond because they presence of the delocalized electron. So there is no band between the gap, there is no back gap between the conduction band and the valence band. So that means the electron will be can flow easily from conduction band to valence band. This is the info. Okay, so we actually also discussed in our previous discussion. Okay, so when we study from our notes, the scheme maybe will be a bit different. So we try to relate our notes to the answer needed from MPM. Okay, so this one is recall back the question from question 6. So here you can see the question asking you regarding the titanium and germanium. The answer given, firstly, you have to discuss the configuration. Then they have the same electron balance here. And we discussed about the energy gap, right? For the last discussion. So we discussed about the titanium. There is a good electrical conductor, so there are no energy gap, right? So germanium is a metalloid, so they have the small gap between conduction and the valence band. And we discussed the temperature will be affected the conductivity of the semi-metal and metal at the question. Okay, so you can look at the common mistake made by the student in 2012. So firstly, student not compare two elements, they compare overall. So in our notes, the info is actually discussed about the trend. So you have to try change the info to become discussion when we compare the two elements. And then the second, we can use the delocalized concept in the discussion of the conductivity, but the scheme are given that they not involve the delocalized electron. Okay, so that means we can involve the concept of delocalized electron in our answer when we discuss about the conduction. Then again, the Laporan Peperiksaan 2012 also mentioned that the student is discuss the conductivity of the element of titanium and germanium based on the conduction band. So that means the answer here, you can actually discuss this localized electron concept and also the conduction band so that you can get 10 marks. The answer from the reference book is like this. Discuss the trend in the electrical conductivity in group 14 elements. So firstly, you have to discuss the trend. Going down group 14, the structure of the element changed from the covalent giant to the metallic so that the electrical conductivity increases. And then the second, in this reference answer, they only discuss the present and absence of the delocalized electron to conductivity. They did not give the discussion in the energy band. So firstly, carbon is a non-conductor as all the electron valence are involved in the formation of covalent bond. No delocalized electrons are present. And then the second, germanium and silicons are semi-metal and hence have an intermediate electrical conductivity between metals and insulator. And then tin and lead are good conductor due to the presence of delocalized electron in the giant metallic structure. So here it will be 4 marks reference answer. But I advise you to add on the discussion of the conductivity in terms of energy band also. So you have to add on energy gap between the valence band and conduction band is large. Electron cannot jump to the conduction band from valence band. Energy gap between valence band and conduction is small for the semi-metal, so that the electron is still able to jump from the conduction band to valence band. And then the last one is the discussion regarding the tin and lead, which is a good conductor. There is no gap between the valence and conduction band, so the electron can flow easily from conduction band to valence band. So actually here we have more than 4 marks point already. So since most of the students cannot score very high grade in this sense. So I think this because the marking scheme is not consistent. Sometimes like this, sometimes different. So why not we include all the related info based on the Laporan Peperiksaan. So I advise you add on the energy gap concept in this question, although the scheme from this question is only discussed about the concept of the delocalized electron. So here we discuss 2 parts. For sure, we will meet the scheme, especially when the marks given is small. Here 4 marks, maybe the scheme will give only the discussion about the delocalized. We don't know. So sometimes you see just now, but the Peperiksaan and Laporan we only able to refer in 2012. Regarding the question before that we do know. But according to the Laporan Peperiksaan for the 2012, where the discussion regarding the germanium and titanium, so the Laporan mentioned that the students able to explain numbers of delocalized electron. Then and also some discuss about the conduction band. So according to this Laporan, that means two of the concept can be discussed in the answer. Although the scheme I given to you in the last discussion for the question 6 is not involved for the concept of the localized electron, but the scheme from the 2013, the answer given here, all the point is only regarding the present and absence of the delocalized electron. So my advice is, why not you just add on another concept here to get 2 marks. So the next will be the explain the inner pair effect as applied on the lead of the group 14 element. Okay, 3 marks. So here also the info from the notes, inner pair effect. Okay, so from here you can see the notes mentioned the first point here is each element has 4 outer electrons and S2 and P2. Shading of the outer shell for carbon and silicon is quite efficient. So this is the configuration electronic for the carbon and silicon. So it is impossible for them, for the small atom, to have an inner pair effect. So that means the inner pair effect will be occur at a large atom, such as here emphasizing at the lead. So this is because the loss of the 2 electrons does not produce an electronic configuration that sufficiently stable. So they are stable, so that means there will be the electron at the s orbital will be excited and go to p, and they can form for bonding, which is sp3. So they will be stable at the +4 oxidation for small atom. They will not face any inner pair effect. So while for the large atom, for example here given germanium, tin and lead, but actually we discuss more about the lead. So you can see from the figure here, the lead actually they have another 2 orbitals, p and s. So they have many electrons in their inner shell. So and give the, so they not offer the effectiveness of the shading effect, so that the attraction of the nucleus to the orbital sec x will be higher. So that means that the the electron in the sec x orbital will be inner, will be act as an inner pair, so will be not involved in the bonding. So that means only 2 electrons from the 6p orbital is actually involved in the bonding. So that you can see here, here also mentioned that there is a large energy gap between the sec x and the 6p orbital. So when the gap between these 2 orbitals is higher, so the electron from the sec x is not able to jump to the 6p. So this effect is known as the inner pair effect, and mainly we discuss in the lead. So conclusion here, lead will be behave as only have 2 electrons in their outer shell, but actually they have 4 and stable at the +2 oxidation state. So this is the general what the notes already tell you. Okay, I just go through and do the revision together with you. Okay, so explain the inner pair effect as applied to lead of group 14 elements. So here we no need to explain the train. We go to the inner pair effect at the lead. So 3 marks. The first, large atoms such as lead with presence of the 5d and 4f electron do not offer effective shading from the attraction nucleus. So that means the shading effect is lost, especially for the 2 electrons at the sec x orbital. So they will be tightly bound by the nucleus and behave as the inner electron. So this one I already explained. So they will be maintained at this state. Here, +2 for the lead. Okay, so inner pair effect of lead is due to the failure to use the 2 sec x electron for bonding, either be share or transfer. So behavior of lead to show valency of 2 less than the group valency through the failure to use the 2 electrons to share or transfer. So this is known as the inner pair effect. So this one is the definition. I can say that for the inner pair effect, but this statement I know that from the notes. Okay, so the lead will be behave as if they only have 2 outer electrons, and then we form stable compound of +2 oxidation state. So that means although they have 4 electron valence here, but due to the inner pair effect, so these 2 electrons at sec x orbital will behave as inner electrons. So there will be only 2 electrons from the 6p will be involved in the bonding. For the repeat exam, no any Peperiksaan Laporan can be pulled out. Okay, so silicon dioxide is an acidic oxide and dissolved in an aqueous solution of the sodium hydroxide. So again, you see here is also the similar or almost similar question in 2013 section C. So that means same year they come out the repeating question at the same section. Because now I discussed the 2013 repeat question and come again the same question of the year. So that means the repeat exam can come up same chapter question also lah, right? So write the equation. Okay, so this one should be no problem now. Just write down the equation between the silicon dioxide with the sodium hydroxide. Okay, and then you get salt with water lah. Okay, so actually this is a neutralization process lah. Since the silicon dioxide is acidic and react with the sodium, so we will form salt and water. Okay, the second, explain why hard water which contains calcium ion is not used in the preparation of aqueous solution of sodium hydroxide. Okay, so here, okay, it's actually it's quite similar for Geolite 4.19 page 18. So then we have discussion about the Geolite is the ion exchanger to soften the hard water by replacing the calcium to the sodium, right? So here you can just use the info there, okay, and try to relate to the question. 2 marks here. So you can see calcium will be react with the sodium hydroxide to form calcium hydroxide precipitate. So you give the equation and the statement. So you can get 2 marks. Okay, so now E, explain how chain silicate are formed. You see again, similar to the question, section B we discussed already, 2015, 2017 ulangan. So that means if you study all questions of the past year, you can score. But the answer you refer must be able to meet the requirement from NPM as much as possible lah. Okay, so again here will be the revision for the section 4.17.2, chain silicate at the page 17. So there are 2 types of the chain silicate here. Okay, so first will be the pyroxene. Okay, it's a single chain silicate. So you have to memorize their structure. So the common factor, single chain silicate. So each unit of the SiO4 4- be linked together by sharing the 2 oxygen atoms, so that they can form a long linear chain, right? So you have to memorize these 2. And then the repeating unit for the chain silicate here will be SiO3 2- ion. You have to memorize. We have already discussed similar question at section B already. So physical characteristic will be brittle and break easily. Why? So here is the reason. So the forces holding the individual single chain together are van der Waals forces. So this is the reason. And then you have to memorize the example. Sometimes they will ask you to give example, or they give the name for the example, and you have to identify whether there are chain silicate or others. Okay, so here we have the example: sodium silicate, magnesium silicate, calcium magnesium silicate. So this is the info you have to memorize. Another one is a double chain silicate. Here is the name of the group. Okay, amphibole. So you have to know the structure. So common characteristic, they are double chain silicate. Why? Explain they have this common character because the SiO4 4- ion unit will link together by sharing 2 or 3 atoms oxygen, okay, with other unit. And then again, you have to know they are repeating unit, which is the Si4 O11 6-. Physically, the physical character will be also the same, brittle and break easily, because they also holding together with the weak van der Waals forces. And give the example here, asbestos. Sometimes question will give you asbestos. You have to identify whether it is a double chain or single chain. We already discussed at section B at the previous lesson. So this is all important info you have to memorize. So first, the question asks you how chain silicate are formed. So you have to discuss because of the single chain will be sharing 2 oxygen atoms, and for the common characteristic for the double chain will be the sharing 2 or 3. and then we have to give the repeating unit. So you can see, we memorize the same thing, but the way to apply in the question sometimes is different. Actually, not different, same answer, but the way the question asked is different. Okay, so firstly, you have to give the first type of the chain silicate form. So the first will be the peperiksaan. So each SiO4 4- unit link with the others unit, okay, by sharing 2 oxygen atoms to form a long linear chain. So this is the way how single chain silicate is formed. And the repeating unit will be the SiO3 2- ion. And another 2 marks we have to discuss regarding the formation of the double chain silicate amphibole here. So the amphibole will be formed by some of the SiO4 4- unit linked together with sharing 2 or 3 oxygen atoms. And the repeating unit will be Si4 or 11 6-. So that means sharing 2 or 3 atoms for the single chain, 1 mark, given the repeating unit, 1 mark. And then amphibole will be linked or sharing by 2 or 3 oxygen atoms with their respective unit, 1 mark, and you give the double chain silicate repeating unit, 1 mark. So total you get 4 marks here. Question number 9, this one will be the question in 2014. Okay, so 2014 we had able to refer our Peperiksaan Laporan so that we can know what is actually required by MPM. So the group 14 element of the periodic table show a marked change in their physical and chemical properties on deciding the group. So here we also discuss the train because the question asks you regarding the group. So we not compare each element, but we do the train. So that means we need to have the general discussion about the changes of physical and chemical changes when going down to the group. Here discuss about the variation of stability of the oxide of the group 14. So you see oxide of the group 14. So that means they have 2 oxidation states. So you have to mention, right? Here we discuss about the stability. So it will be the thermal stability. We, from the notes, mentioned that the group 14 have the valence shell configuration, which is the NS2, MP2. So what we learn, we know, we just keep as long as the information is not wrong. So this is the general. But we have to give the point where discuss about the thermal stability, not about the acid and base property. The generally one statement can be stated at the front, especially when the question discuss about the train, discuss about the whole group. Here you can see element 14 have 2 oxidation states, +2 and +4. Why they can +2? Because they only use 2 electron at orbital P. Here you have to give in the +2 oxidation state compound here. Okay, involved here will be the monoxide group, which is the carbon monoxide, silicon monoxide, germanium, tin and lead monoxide. But here I advise you to give the stability, thermal stability for each of the monoxide. Carbon monoxide until tin monoxide will be less stable for the +2 oxidation state. +4 will be carbon, silicon, germanium will be more stable. Okay, and then the +2 will be for lead. So here PbO will be stable. Here will be less stable. Then here carbon dioxide until tin dioxide will be stable, and the lead dioxide less stable. Why? Because the stability of +4 oxidation and the covalent character decreases. Okay, when going down to the group. So we have to explain. We have to explain the train, see or not, generally. Okay, I already set in the red color already. So this is the point where we have to write. according to what we learned in the notes already. So notes also have this table lah. So you can see +2 will be increased, then +4 oxidation state will be decreased lah. So that the lead dioxide will be less stable, while the lead monoxide will be more stable. Okay, and then because the question for this is involved for many marks, right? 2014, 8 marks. So we have to discuss more detail regarding the inner pair effect. I already explained just now why the lead have more stable at +2 oxidation because of the inner pair effect. So we discussed about the size is big. We discussed about the 5d orbital, 4f orbital. Okay, not offering the effective shading from the attraction nucleus. So that means the electron at the s orbital will be behave as the inner electron. So it's not involved in the bonding. The bonding is only involved the 2 electrons from the 6d orbital. Hence, again, discuss about the lead will be more stable at +2 oxidation state. 8 marks. So you see, 8 marks you have to give a lot of the points. So are you sure you give only 8 points is enough? You learn so many things. So give more explanation. We do know how many marks is involved in the inner pair effect. So the reference answer here will be monoxide group of 14 involved will be carbon monoxide until the lead oxide. Okay, for the dioxide group will be carbon dioxide until the lead dioxide. So this is what involved. And give the equation. Okay, give the equation. 1 mark. Going down to the group, stability of monoxide decreases due to the inner pair. See, we need to give the trend. We not only give the comparison for each, you need to give the generally what is the happen. So here the actually that means the +2 oxidation state will be increased also correct due to the inner pair. You see, inner pair effect 1 mark. For this sentence, you get 2 marks according to the reference answer. Okay, so going down the group, stability of the oxide decrease because the character, the ionic character increases. The lead oxide, lead monoxide will be ionic compound, right? So that means the stability of the group will be changed from the covalent. You see, covalent character decreases and to become more ionic character. So here also 2 marks. So you see, these 2 statements already 4 marks. They discuss generally, not compare one compound to another compound here. So you give the equation where the lead dioxide is where they are +4 oxidation state is not stable, will be tends to become or to form lead monoxide which is more stable. So you give 2. This all you get 2 marks for the response. Okay, so I have do some comparison between the scheme I already discussed with you all in last section. Is 2010. You see, what is the point meet here? Both discuss the monodioxide group of 14 and dioxide group of 14. Both give the equation. And then both discuss the stability generally and due to the inner pair effect. And then they also discuss about the lead monoxide is more stable and the character is changed from the character, covalent character to the ionic. But you can see the difference here is the 2014 reference answer here that not discuss much about the inner pair effect. But 2010, where we have another 2 points here. So my conclusion here, again, we need to give more points. We need to give more points based on the Laporan Peperiksaan 2014. Firstly, you can see that they explain the stability variation. So that means we are meet the point if we give the +2 and +4 oxidation. You see or not? When we go to the discussion about the oxide group of 14, both of the scheme are given just now 2010, 2014 is not include discussion for this +4 and +2 oxidation. But we can refer for the acid and base property, we have Laporan Peperiksaan. The Laporan also mentioned that most of the candidates are unable to set the variation stability for the oxidation state of group 14. in oxide. So remember, when the question asking you about the oxide of the group 14, please mention their oxidation state, +2 and +4. The red color one is the scheme answer. The black color one is the answer I add on based on the discussion in the Laporan Peperiksaan 2014. So you see, 2 years, although they're asking about different questions, one is about the stability, one is about the acid and base property, but 2 of the Laporan also mentioned that students not mention or ask you to, you see here, student already able to explain variation stability. Both of the Peperiksaan state that students have to give the oxidation state when discussed about the properties, chemical properties or physical properties regarding the oxide of the group 14. Okay, and then the next will be the equation you have to mention. Okay, so both of the scheme 2010 and 2014 also give the equation. So that means equation is very important for your answer to meet the requirement for MPN. So here, okay, student also able to state which is stable. So I change the scheme. You see, we give the less stable to carbon monoxide, and this one stable for lead monoxide. Correct or not? This one is +2 oxidation state, and then stable for carbon dioxide, less stable. Okay, so here change here the message here. Okay, I advise you to give not only all the elements involved in monoxide and dioxide, give which one is stable or not stable according to here. You see, student not mention which is stable one. Not mention oxidation state for oxide 14. Okay, this one have to state the stability. State the particular group 14, and then you have to give, you see, stability oxide in +2. Okay, and then you have to give the inner pair effect. So add on more point regarding the inner pair here. Since we already know about the reason why they become in effectiveness of the shading effect for the lead, and then discuss also the ionic factor increase when the state oxidation of +2. So here going down the group stability of the dioxide increases because the ionic factor increases. So we add on more than 8 points if you want to meet what Laporan Peperiksaan. Okay, so from the section C, question 10, okay, it's discussion regarding the Stpm 2015. So you see here, discuss thermal stability, almost the same question. Just now we just explained. 2014, section C, right? Just now we explained. 8 marks regarding the thermal stability between the oxide group 14. So here, change a bit. Discuss the thermal stability in tin 4 oxide and lead 4 oxide. So again, we discuss the configuration. We state the oxidation state because they have +2 and +4 for group 14. And then for the +2 oxidation state, what monoxide of group 14 is involved? +4, which is involved also, just now we already discussed. And then +4 oxidation state will be stable for carbon to germanium. So that means carbon dioxide until germanium dioxide will be stable. And then +2 state of lead is more stable. So that means DBO will be stable because the oxidation state of +2 is increasing when going down to group. Okay, so we discussed about the covalent factor decreases or the ionic factor increases when going down to group due to the inner pair effect. So we discuss all the same thing. You see, we read the same info from the notes again. Okay, you give equation Okay, but here we more discuss about the comparison between the two compounds here, not train. So 5 marks. We straight away discuss lead 4 oxide lead 4 oxide is thermally unstable, okay, because lead is stable as lead monoxide, okay, or lead 2 oxide lah. So it decomposes to lead 2 oxide and release oxygen. So you give comparison, lead stable decompose to form lead 2 oxide which is stable, and we give equation. And then for the oxidation state, you see you have to mention tin is stable at +4 and lead is stable at +2. See, this is a report from the MDM Laporan Peperiksaan. The first candidate able to compare the relative stability +2 and +2, +2 and +2. You see, when discuss about the group 14 oxide, always emphasize on the oxidation state +2 and +4. So here 2 marks is involved already. If you discuss regarding the +2 and +4, if let's say you just compare which is stable, you not get the 2 marks. And then the next, the problem made by the student, the mistake made by the student is that actually reverse the theory already, because the more stable for lead group of lead oxide will be the lead 2 oxide is more stable compared to the dioxide, right? So you have to give the balance equation. Here is correct formation. The wrong here is the unbalanced equation. See or not? So we have to give the correct and balanced equation now. Okay. So here we have to give correct equation, which is balanced. And okay, the mistake I just mentioned already lah. Actually reduce to PB, change to PBO, right? To oxidation state. And here student not mention, I mentioned already lah. Always not mention the relationship about the oxidation state to the thermal stability lah. So you have to always mention oxidation state to any properties. The first we discuss the acid and alkaline already. Next will be the lead 4 oxide. Okay, lead 4 oxide, or here lead dioxide, right? Okay, to be prepared by the lead 2 nitride. So solution with correct 1 solution under control condition as shown by the ionic equation below. So the reaction is redox reaction. So here is mentioned to you. This is the redox reaction already. Actually, this is also one of the examples we discussed at 2007 section C already. But the question not give you the ionic equation is redox reaction, but here give you already, so will be more easier. So firstly you have to give the reaction involved 3 marks here. You have to give also the oxidation. You have to give also the observation. Okay, so 4 marks. So from here you can see the lead is oxidized from Pb2+ to 4+, and then the ion chlorine will be reduced from +1 to -1. So this is the redox reaction. So we have to discuss. Firstly, Pb2+ is oxidized to Pb4+. Then this one, CiO- will be reduced to Cl-, and then we give the Pb2+ here is act as the reducing agent, or ClO- will be oxidation agent. So that means for reaction, redox reaction, we have to give the agent for the reactants. And then 1 mark will be the observation. Dark brown precipitate is formed. Okay, this is the PbO2. You can look at the Laporan Peperiksaan. So most candidates were able to give the oxidation of the Bamblen 2+ to Bamblen 4+, right? And also the ClO to Cl-, no problem. But students unable to give the observation. So here the PbO2 is dark brown or black precipitate. So actually it is almost the same question in 2007. I already give the answer and together already. Okay, so I should discuss lah. So calculate the volume of the 0.105 mole per dm cube Cora 1 solution required to produce 1.40 grams of lead 2 oxide or lead dioxide, also the same, right? Okay, 3 marks here. So here the equation is not give the mark because the question already give you, but you have to use the equation here. So from here, the PbO O2 here, numbers of molar will be 1.4 divided by the PbO molar mass lah, or Pb207, oxygen 16.0 lah, you get from the table. So you get 5.86 times 10 negative 3 molar. So from the equation, we know that 1 mole of PbO2 lead 2 oxide, okay, will be equal to 1 mole of ClO minus. So that means the ClO minus, which the question requires you to find the volume, will be this lah, divide. You get the answer already. So molar equal to MV 1000, right? So you change lah. We want to get this one. Okay, so mole times 1000 divide mole given here. So you get 55.8. So the mistake made by students here, wrong unit and give the wrong significant figure. So here all is 3 significant figure, you see. So answer must together with the 3 significant figure. So we keep according to the significant figure from the question. So here will be 3 lah. The next, the melting point of the silicon is 1510, while the melting point of the diamond is 3550. So here, ask you to discuss the difference of the physical properties between the silicon and diamond, okay, based on their melting point respectively. So this is also the same question we already discussed at section B 2015. So when we discuss about the melting point, so you can look at the table here. So this is the overall. I discuss the overall first because we want to do division together. Okay, so melting point of carbon, silicon, and germanium much higher because they are giant covalent structure compared to the tin and lead, which is in the structure of giant metallic. This because the carbon, silicon, germanium exist in the giant covalent molecule. Okay, but here you see carbon and silicon both is in same giant covalent structure. The common mistake made by a student, they will see that the silicon has a less melting point. They will assume that the silicon will be simple molecule. But here, actually, both of them are giant covalent structure. When going down to the group, okay, so there is increase in the metallic factor. Here, the lead and the tin. So this is due to the molecular forces decreasing down to the group, okay, resulting in change of the strong covalent bonding to metallic bonding. If you discuss about the covalent structure such as the carbon, silicon, germanium, you have to discuss the size. Where the size of the carbon is less than germanium, the length of the M to N will be increased, so the strength will be decreased, the melting point will be decreased. If you discuss about the giant metallic structure, the melting point of lead is higher. Okay, we will assume that according to theory, the lead should be as the lowest melting point. But here, because of the structure for the tin and the lead is different. So the lead have the closer packed structure, which is base, center, cubic, and the tin is in the tetragonal structure, which the atom to atom will be more further apart. So here we have to discuss carbon. Okay, because the diamond is the electrode for the carbon. So we discussed both actually they have the same structure. Why silicon has lower melting point? Because the size of the silicon is bigger. So we discuss this. Melting point of the silicon, it will be lower compared to diamond. Okay, so what's the discussion we need to involve? As I mentioned already, firstly you have to state that both of the silicon and diamond have the same structure, which is a giant covalent. Carbon atom is smaller, so the C to C bond require more heat to broken. So we get 3 marks. So the Laporan here mentioned, students common mistake here, they assume that the silicon which has a lower melting point is actually the molecule, simple molecule structure, but here both have the same structure. So this is the first mark here to give. Okay, you not only compare the size, compare the bond length, compare the strength, you have to state the structure first. Where both have the same type of structure, the different boiling point here is melting point is because of the size, causing the length between the bond different and the strength of the bond will be different. So this is the more common mistake did by the previous candidate. You have to give the size of the atom. This one should be no problem. But if let's say you already starting with the different structure, you won't give the size and you won't give the length bond between the carbon and silicon to silicon already. So when you start the structure different, you will discuss about the van der Waals already, right? So it will be totally wrong. So same structure, discuss the size, discuss the bond to bond length, and discuss the strength of the bond. Question 11, 2016. Okay, so N is the element of group 14. Properties of the N tetrachloride and the N dioxide are given below. Okay, so here, the first statement here is the N tetrachloride thermally stable liquid react with water to form low pH value solution, right? And then the second, the dioxide of the group 14 dissolved in a hot concentrated solution of the sodium hydroxide, but does not dissolve in acidic. Okay, so from here, you have to determine what is N, 4 marks. So firstly, discuss about this. When we react with water, that means we discuss about the hydrolysis. So as we know that in the group 14 tetrachloride group, okay, so the carbon not able to undergo hydrolysis due to they do not have the D orbital, right? Okay, so here you see they are all hydrolyzed by water except carbon tetrachloride. So I already summarized in the table. So all yes, only the carbon tetrachloride no. So the equation for the hydrolysis will become dioxide and produce the hydrochloric acid, so that they have the low pH value, which is acid. According to the notes here, okay, so for further discussion, why the silicon until the lack of the tetrachloride able to undergo hydrolysis, because the use of the empty D orbital in their valence shell to allow the water ligand to donate their lone pair to form coordinate active bond with water molecule. The coordination facilitates the hydrolysis. So that means they need empty D orbital to undergo the hydrolysis. So here will be how the silicon tetrachloride undergo the hydrolysis. So the question for the first, we are very clear that there will be not carbon tetrachloride, will be another 4. So second, you can see the N dioxide dissolved in hot concentrated solution. So that means this is the acidic. Okay, so this is the acidic. So based on this, the carbon dioxide and the silicon dioxide will be acidic. But from the first statement, we know already there is not carbon. So there will be silicon dioxide. Okay, you see acidic will be two possibilities. And we know already from the first statement, there are silicon, germanium, tin, and lead. So we know first answer, N is not possible for carbon. Okay, because carbon not able to undergo the hydrolysis process. Okay, so the N will be others lah. They should be have the D orbital. Okay, which can accept the lone pair from the water molecule. So you have first statement, the N is possible for silicon, germanium, tin, and lead. And then the statement number 2, the NO2 is acidic because it only can react with the alkaline. So it must be silicon already lah, and not possible for germanium dioxide until lead-2 oxide because they are amphoteric. So we confirm that the N will be silicon. So mark. Okay, so next you see again the question asks you about the acid-base property, but here together with thermal stability of the oxide of N. So as I advised, when question asks you about the oxide, you have to mention there are two oxidation states for the group 14 oxide, right? Which is +2 and +4. So 7 mark. Okay, so firstly, the question asks you about the acid-base property thermal stability for oxide of N. So for sure, you need to know the oxide of N we have two. See, silicon monoxide, silicon dioxide. So discuss about these two properties, and from the table, the silicon monoxide will be neutral. Okay, and then the dioxide will be acidic. Just give silicon monoxide neutral, dioxide acidic, based on what you learned in the table already. And then because the silicon dioxide is acidic, so that means they will have their own reaction with base. So give the statement, silicon dioxide can only react with concentrated sodium hydroxide to form silicate. Okay, or you give the equation. And then the next you have to discuss the thermal stability. So from here you can see +2 oxidation state for the silicon monoxide will be not stable. Okay, because there is a simple covalent molecule with weak van der Waals forces. If let's say the structure is giant covalent structure, so that means the discussion will be in the Si and O bond. So that means here silicon, so the silicon dioxide is unstable because from here simple covalent molecule is weak van der Waals. Okay, and then you have to give the equation where the silicon monoxide will be disproportionate to silicon dioxide and silicon. So one more discussion for the structure and bond. So here you have to discuss because there already is a simple covalent. And last, you have to give that the silicon dioxide is stable. Thermal stable silicon, you have to discuss the Si and O bond. So when the molecule is a simple covalent molecule, we discuss van der Waals. When giant covalent structure, we discuss the Si and O bond. Okay, so this is the 7 mark already. Okay, and then here write chemical equation for the reaction of N tetrachloride with water, and explain why N tetrachloride is liquid at room condition. Okay, so here write equation. So from here we actually just now explained already lah. So silicon tetrachloride will be undergo hydrolysis to form silicon dioxide and acid hydrochloric. This should be no problem. Then why they are in room condition is in liquid? That means the melting point is very low. So when melting point is very low, we discussed about the intermolecular force, right? Which is a van der Waals between the molecule. Okay, it's weak. Okay, so relate to the bond. Okay, so here, physical properties of the tetrachloride, you have to study this part. So basically, we discussed the melting point if T is increased. Okay, because here we have actually two bonds. One is the X with Cl covalent bond. Okay, but here we know already the tetrachloride group 14 is actually the simple molecule. So the intermolecular forces will play the role affecting the melting point already. Discuss about the intermolecular forces between MCl4. They are weak van der Waals forces and they are all Valentine liquid. So we discuss this. We not discuss covalent bond because they are weak. They have low melting point, so will be caused by the van der Waals, and they are actually the simple molecule. Okay, not giant covalent. Okay. So when we discuss about the van der Waals forces, we discuss the size. When the size of the molecule increases, the numbers of electrons in the molecule increases. So the strength of the van der Waals increases. Melting point and boiling point of the tetrachloride generally increases. Okay, but here we have the common mistake. As I mentioned just now, we will discuss about the bond between X and Cl. So, but the X and Cl bond is actually the covalent bond. So the group 14 tetrachloride group is actually simple molecule. If let's say we want to break the XCl bond, it also need a lot of energy. So if let's say we discuss the thermal stability, actually is decreases because the covalent bond is due to the size of the element and cause the length between the M and X bond will be affected. So if let's say we discuss carbon to Cl and Si to Cl, so the carbon to Cl bond will be higher, okay, because the size of the carbon is smaller and the length between the C and Cl will be shorter. So the thermal stability will be decreased when go down to the group. So you see the difference. So this is the common mistake made by students. So here I summarize, when we discuss melting point, we discuss about the intermolecular force for the tetrachloride group. When we discuss the thermal stability for the tetrachloride group, we discuss the covalent bond. So when we discuss melting point, they will increase. Okay, because the size of the group 14 increase cause the van der Waals forces increase. When the stability, when we go down to the group, the size increase, the bond to the Cl will be increased. So the bond strength will be decreased. So the thermal stability decrease. See a lot. This is a more common mistake will be done by the students. 4 marks here for this question. We already discussed this will be the answer for hydrolysis from silicon dioxide and hydrochloric acid. Okay, so here we discuss about the room condition, which is in liquid. We discuss the melting point. We discuss they are simple covalent molecule. I see. So when simple covalent molecule, they will hold together by the weak van der Waals. So we not discuss the M and Cl bond. We discuss the intermolecular forces. Okay, so very little energy is required to overcome the weak van der Waals forces. So I think this question 12 I will discuss later on. So I hope that today's discussion, which I relate to Laporan to Peperiksaan, will help you understand what the MBM requires and what is the common mistake made by the previous candidate. So that's all for my sharing.